Okay, now that we have Landsat images downloaded, we could open them in ArcGIS and we could visualize them, do some calculations using map algebra. I'm going to show you how you can also read these in Python. Um, for that, we need to open, let me just create a new session here. I'm going to say Anaconda. Okay. Uh, we created an environment for a class, and that environment is AGIS. So I'm going to say activate AGIS environment. Here it is. My files are actually located in D drive. So I'm going to navigate to D drive and then come to this space. If you are in the C drive, you are already in C drive, or if you are in Mac home directory, there are ways that you can navigate. For example, CD um, dot dot goes one level up, or if I want to go to the D drive, I can say D colon and goes to the drive D. Here I am going to actually open Jupyter Lab. Jupyter Lab also is installed if you have followed me um, with the previous videos. So your Jupyter Lab should be installed, your packages should be installed. We are going to, let me see, I am in the Dropbox and I'm going to go to my teaching folder and going to find my AGIS here. I'm going to create a new folder right here and name it codes because I want to save my codes in this one. And then here I'm ready to create a new Python kernel, a notebook, a new Python notebook. I'll create on that, and I have a new Python notebook here. Um, Hold on, let me find some of my. Okay, so now we need to import raster IO, and we need to import numpy as np. Also, something that we need for visualization um, is matplotlib. So I'm going to say import mat um, matplotlib dot pyplot as plt. Okay, that's good. And sorry, I did this very fast. But once you have those, you can um, so this is, we call it one cell in notebook. Um, so once you are writing the code basically is just a text. But now if I use Control Enter, um, then that code, that line or that cell will be implemented, will be executed, and then um, Python knows that those values are read, those values are imported. So that's how uh, these work, and different cells help to basically be organized or code. Um, I'm going to just slowly not teach these and make you comfortable with Python, uh, but there are so many things. Um, I'm just trying to teach you those essential things for this practice. So you need to be patient with me in this process. So there's a sample code that we are using to read raster layers, and we are using the raster IO library for that. So the sample code starts with. I'm going to say from raster IO dot open function of raster IO. I want you to open something, but what? So before that, I want to bring it the address of a layer. So I'm going to say um, Landsat or LSB1, Landsat B1 or band 1. Let's start with band maybe 4, 5, right? Let's start with band 5. ls band 5 address. Um, Note that I'm separating each of these phrases by underscore. We don't use space here. And say equal. In Windows, we need to put R for the address. In Mac, you don't need to. Um, and then we want to get the address of the Landsat band 5 visit. I'm going to open this. Let's go to the details view. These are the names. Um, let's find band 5 reflectance TIF. So we want TIF file because we want to read TIF file. And band 5, this is the TIF file. This is the type of the file is TIF. Be careful which one you are reading because there are others like AUX extension. One thing that you can do in Windows and is holding the shift key down and right click on the file, and then you will have the option to copy this as path. It doesn't copy the file, it will copy the path of that file in your machine. In Mac, you should hold the option key down, if I'm not wrong. Um, so copy that as path. So that is copied in my clipboard. And now I'm going to, it is copied as a text in quotation. I'm going to control V here. As you can see, the entire line is pasted here. Um, and it comes in double quotation, which is good because this is a string. This is an address, and the address comes in a string format. And this R helps the software to know that this is the address, and these um, slash forward slashes or backward slashes. I always often confuse. Um, these are for separating different levels in the directory. Um, so now, again, once it is a text, it is not implemented, it's only a text. But if I use Control Enter, that cell is implemented. Okay, now I can use that name in my raster.io open function and say open this file. Great. Raster.io also has some flags that we can add this by those flags, for example, read. There are other flags. We have read plus, we had W for writing, but R is only for read. I think it is read only. And then I close the parentheses for open function, and I say read this file as, we call it RST, and name it RST. Read that file, name it RST object, and then here, because we are using the width format, I'll explain what width format does. We go to next line in an indented line, and then I'm going to say this will be an array. Array of band 5. Array is basically just a sequence of numbers. Is so from rst.read, use the read function. You read the first band because band 5 itself is only one band. Read the first band um, and just put it in array b5. Um, and let's read that and see what happens. So I can say array b5. What are you? It is an array. It's a two-dimensional array, has some rows and columns. These are basically the cells. These values are the values of the cell. If you are seeing these zeros, those are probably just the edges of the raster. If I say what is the mean of these, so now it is a numpy array. This array is numpy array, and we are using numpy array here. So uh, numpy as a library, um, and I'm saying, okay, what is the mean value of u? It is 8,000. And we said that for reading this, we need to also scale them, right? How can we scale them? I'm going back to the handbook here for reflectance values, that's the scaling factor. I'm going to copy that here, and I'm going to say, once you read that, multiply that by this number, and then minus that number, right? Um, in this situation, multiplication will happen first because that's is the priority of operation, and then this part will happen next. So first, that will read the array, then will be multiplied by this, and then this will be subtracted from that, and that will be our array um, RB5. So area B5, now the value changed because we scaled it, right? So um, there are nice things about this that you can do. Do you remember the histogram in ArcGIS that was not really great? I'm going to here import Seaborn as SNS. Seaborn is a library that um, does visualization. After adding that, I implemented the cell again with Control Enter to make sure that that value is um, applied. This library is read, and now I can say from SNS use, what can we use? We can say I think it's his plot. Yeah, his plot, and um, plot the histogram of our B5, the array of B5, and now this is going to uh, show the histogram of the array and how those numbers are distributed. Um, Takes a little while, we'll see. We don't have many. I wonder why it is taking a while. Um, okay, let me explain what this with function, with format does. This with reads this part and names it as RST, and then when we open a file we also need to close it, but in order to just write that in a block we use with. So when you come to the with block, so it is open, we do anything we want with it here, and then after going out of the block the file will close it automatically, will be closed automatically, so we don't need to manually say raster.io.close that file. That's why we are using the read function. It is interesting that it's taking a little while. Let me stop this to see what the problem is. For some reason it is taking a little while and it is not normal. I have to look into this and see why it is taking a while. So I restarted my kernel using restart kernel and clear all outputs. I'm running this again because I restarted the kernel, so there's nothing in the kernel. I have to execute these cells again, um, reading the libraries, reading the address of the file, and then opening that file. Um, and then here I can say what is the average of the array value, and here also I can say what is the shape of this array. We say it is a 2D array. It means that it has rows and columns, and this shows that how many rows and columns it has. Um, it has about 7,000 rows and 7,000 columns. If I go to my ArcGIS and I'm going to the properties of this band 5, and I'm going to say in the source give me the raster information here. You can see that those are still the same number of columns and number of rows. Those are exactly the same number, they have to be the same. Number of bands, because we are reading only this band itself, band 5, it is 1. There are formats like JP2 formats that they can have more than one band in one file. Then you will have multiple bands. Cell size is 30 meter because we know Landsat band 5 is 30 meter. I'm going to show you, and also the format is TIF, and um, and there's another thing here. the pixel type is 16-bit integer. And also one thing that we need to know, no data value is 0. So the value of 0 means there's no data. That's why when we read it in Python, um, when I said print rb5, I said print that, now it is actually -2. Um, it, it was 0. First it was 0, and actually I think I did a mistake because uh, when I scale this, that 0 also is scaled, which is not supposed to. So what we're gonna do, we're gonna handle that situation. So I'm going to say, hold that for now. Sometimes in these situations, for example, you can put a comment or hashtag here. We'll comment out this part, so this part won't be a code anymore, and only this part will be implemented. So I'm saying that once you read that, we have not scaled it yet. Um, there's another interesting here option that I can say what is the, we call it KWDS of this layer, and I'm going to say um, uh, for RST, from RST, the object of RST, what is your metadata, and copy your metadata and put in this for me. And now when I read that, now I have KWDS as a dictionary here. So I can see the driver, which is the format of that layer, basically is um, geotiff. The D type is unsigned integer 16 or integer 16. The no data value is 0, and 0 is a number, has a meaning, and the meaning is reflectance of 0, which is not the case here. We should somehow handle that here in Python in a way that the software is not confused. Count is number of bands. Width and height are the same as rows and numbers, so width are the number of columns and height is number of rows. And CRS is basically the projection system. And then here in the transform we have an affine object that is, the first value is the dx, which is what is the cell size of in the x-axis, and then the y-axis, which is -13, because we have the square shape cell size. It is 30 meter. This is also, these are interesting, good numbers, because they are the basically the band top left corner coordinate of this raster. So with all this information, basically we can map these numbers. We have a bunch of numbers that are organized in some rows and columns, and with these information, basically the software gets this information and visualizes that as a map for us. So that's how I'm going to use it. I know that my no data is 0, so I'm going to say um, the way that we can get values from uh, dictionary is that pass the key. So this is the KWDS dictionary that we built here. If I want to say what is the value of no data, I can say just pass that value, that is a string, the key, um, and say I say okay, what is that? It says the no data value is um, 0. So here I'm coming and saying that um, make all of the no data values, and in RB5 I can say make all those no data values, I can say basically make them uh, for example mpnan or numpy nan, which is not a number, and I'm going to say in array b5, in any um, location that array b5 um, equals um, equals kwds of no data, which we know it is basically 0. Convert that to if it is no data, just close that bracket, put np.nan, put not a number there, so that will handle that part. And then I can say rb5 scaled, I'm going to scale this, is rb5 and multiply by that number minus this number. This will, oops, this will take care of this, and that should be it. So now if I run this, um, okay, so cannot convert float nan to integer. All I can do here is say this is as type, read that as float 64, converting that to a float to 60 float, converting that value to float, so we can pass that problem here. I'm going to upload this code so you can just read and replace your address and you'll be fine. This is just to show you how this works. And as you can see, if I get the mean of that scaled, even scaled value here, I'm going to get some nan, because there are nan values here. If I say np nan mean or median, and I'm going to say what is rb5 scaled, what is the value, the average value. Now this change, I think actually now this should work better. Let's see, not sure. Trying, probably not. That's kind of odd. I don't know why, but yeah, I'm going to restart the kernel again. That was a mistake. Reading all those again from the top. Okay, now here it is good. So what I'm deleting these. Okay, using dd. Okay. What I'm going to do here is plt from um, matplotlib, that we read plt.emShow, which is the function that shows basically 2D array values. I'm going to say show this in an image, and this should be, there you go. So this is basically the same thing that we are seeing in ArcGIS. And now we handle the corners of these because those were nan, and we converted them to nan values. ArcGIS basically does the same thing. If I bring that here and P5, you see that you don't see the edges here, but in fact there is some value there. That's no data. You see that if I'm clicking here, because this is in the boundary of the raster, it is no data. So ArcGIS is handling that, but here in Python, everything you have to handle that yourself. So it is more difficult, but then also you have more control over that. For example, I could just replace the no data with something else. Um, but that's uh, how you can read different rasters. Another KWDS, let me show you here again. We talked about cell size. Um, I can simply copy and paste. Let's say go back to here, this place, and I'm going to bring TIFF of band 4, shift key down, right click, get copy as pass. Okay, and then I'm going to say end um, here ls band 4. Okay, I've brought band 4 here. That's great. So I can do exactly the same thing with this time band 4. Instead of this, I'm going to change this to band 4, and I'm going to say everything is the same. These numbers are the same for all these reflectance values of band 1 to 7. So from band 1 to 7, you can use these. And go back to, or, okay, what do we need to change here is instead of this band 5, we are calling this band 4. And also I have to replace that here, band 4, band 4, and band 4, and band 4. So as you can see, with a simple copy and paste, now I have band 4. I read these again, and now I can show band 5, and also I can show band 4. As simple as that. And the nice thing about this is now that I have band 4 and band 5 as numpy arrays, I can just say r band 4 scaled, for example, multiply by r, or minus, let's say just r band 5 minus r band 4. Um, so if I do this, the response of this will be exactly a calculation, a simple calculation. So the NaN values will remain NaN, other values will be um, the same. So in NDVI, you know that you need to do something like this, plus. So because, okay, band 5 minus 4, 5 plus 4, and I'm going to call this NDVI, or array of NDVI equals this one. That's done. plt.em show at NDVI. So as simple as that, I calculated, apparently not, r NDVI dot mean np.np non mean NDVI. Yeah, so it is just the values are not great for, um, we need different presentation, but the numbers are correct. The numbers are correct. plt.im show ndvi array of ndvi. I can just get a slice of that in the 3000 range and 3400. The same thing, 3000 range. Only I want to get a 400 by 400 cell there. This still doesn't show much, which we need to change some of the values of the IM show to be able to see the values, but the values are here. These are the NDVI values. So we have the values, but the IM show is not really doing a good job in terms of showing those values. There are some ways that we can change IM show, plt.im show. I think one of them is interpolation, if I'm not wrong. and maybe nearest, if I'm not wrong. Oh, sorry. One of the flags still doesn't work. Anyway, so you see a little bit of dot over there, um, but um, the values are there. So NDVI layer is calculated. Um, the bands are calculated here. That's how you can read these values. I'm going to clean up this notebook a little bit, and then I'm uploading that to our Urban Data Analytics repository in GitHub. So github.com Mehdi Harris / Urban Data Analytics course. Here, I am going to upload this as reading raster, which I actually have here, something that is here, that's from orthoband. So I'm going to create something to read a raster layer. Ortho is something that we're gonna do also later. But for now, just the Landsat layer, and then you're gonna see all you need to do when you want to use my code is replacing the address with the file address on your computer. Everything else should work. Also, you need to install those packages. Hopefully, you already did, and then this gonna work. This was just a quick practice to see how Python can read a raster.